So we're looking at the serverless aspect of application development, although we're focusing in on serverless in relation to web APIs, although we haven't started talking about web APIs yet. And so in last week's lecture, if I go into the section, you have completed this lab. Now, I have added a new section to the lab, but I'll talk about that in a while, I think. And we worked our way through halfway through these slides here. And so the first aspect of serverless that we looked at was the serverless compute options available to us. Let's see, sorry. Serverless compute, which, well, one example of or one offering that AWS provides in that space is the Lambda service. It's not the only serverless compute option, though, but it's the one that we will concentrate on. And what the Lambda service allows us to do is to deploy something as small as a function, and it will provision the AWS service will provision the necessary underlying stack that function runs on. In our case, the stack was comprised of the Node.js platform running on top of a Linux operating system. And so the kind of runtime environment was as simple as this. You had some sort of event source which created an event. We model an event simply as an object, JSON object in our case. That JSON object is targeting a particular Lambda function. And the Lambda service then, and it's important to distinguish between the Lambda service and the Lambda function. The Lambda service is responsible for essentially matching up an event with a corresponding Lambda function. And it provided the event to the function as a parameter. And also, it's important that you understand what the internals of that parameter are, or the internals of the actual event object. And we'll look at that in a bit more detail as we work our way through this Lambda section. And the Lambda function does its thing, okay, which may invariably involve talking to some other services, because all of the other services provide an SDK, software development kit, and we simply use that SDK to communicate with that other service. We also know that all of the services provide a web API interface. We were talking about that when we were discussing the CDK framework itself. But fortunately, our Lambda function doesn't have to talk to a service using raw HTTP calls. Instead, it uses the SDK provided by AWS to take care of that low-level communication. And we talked about the anatomy of a Lambda function. And I guess, I could just click over to VS Code just to remind ourselves. Here's your typical Lambda function. And it has an initialization part. In my case, the initialization part is simply one line of code, but it's still significant because that one line of code, in this case anyway, is establishing a connection with the DynamoDB service. And then we have the handler part of your Lambda, which, okay, I've called handler, but you can call anything, and it's a function, and that does whatever it's meant to do. From the CDK point of view, this is what we put in our infrastructure code. The CDK stack is where all of your infrastructure code is, as you know. And so what we're looking at here is an example of the CDK code to provision a Lambda function uh, within our account. Yeah. And so in this case, the provisioning function, because we are provisioning a Node.js function, there's a nice convenience um, class provided by the Lambda SDK, which in our case is that this Node.js function class. This is an example of what we call an L2 construct in the language of the CDK. You might remember the CDK defines three types of constructs, L1, L2, and L3. An L2 construct, when it gets executed, I guess, if you like, and it gets executed at deploy time, when it gets executed, it results in the creation of typically more than one AWS resource. And in the case of this Node.js function L2 construct, clearly it provisions a Lambda function, but it also provisions an execution role, an IAM execution role for that function, and one or two other low-level AWS resources as well. Just by the way, right, so all of these L2 constructs, I'm going back a little bit now, admittedly, all of these L2 constructs, which are really just classes in the JavaScript world, TypeScript world, sorry, they have three parameters. The scope, which is the first one, some sort of a string, which is just an identifier for that construct. And the rest then is the configuration for that construct. And the configuration depends on this part here. I just collapse this for a second. This part here really depends on what type of construct are you creating. In this case, it's a Lambda function, but it's the exact same. The constructor for these L2 constructs all are the exact same. They take a scope, an identifier, and then a JSON object. But the structure of the JSON object depends on what kind of L2 construct are you dealing with. And if you ever want to find out what are the various p-value pairs in this construct for any particular service, then if you simply mouse over in VS Code and click, and in my case, it's asking me, do I want to declare this or do I want to find its definition? In my case, I'm going to select this one here. Now, where it has brought me to, if you can see here in VS Code, the full path name of this file that I'm currently looking at, it's actually inside in the Node.js folder, if you follow the path name all the way down along. And the last part of the path is the actual file name. And you can see the file name there is a .d.ts file. These are these TypeScript declaration files that I mentioned when I was talking about TypeScript. So this .d.ts file, you will get these files with every L2 construct that is available to you from the CDK. This one here obviously is related to the Lambda service. And so, you can find out more. You won't necessarily need to do this, but it's interesting just to poke around, I guess. So here we have the declaration of the actual class itself. And if we look at the constructor for it, it takes three parameters, as I was talking about, the scope parameter, the ID parameter, and the third one then is what we call the props parameter. And the props parameter for this Node.js function construct has a type. And if I again mouse click on that, it brings me to, I'm in the same file actually, it's defined in the file itself. And so what we're looking at here now is this structure. You can see it's an interface, it's a TypeScript interface. And here's the full definition of the interface. And so, you could read down, you could scan down through it to see what are the various properties. And you can see the majority of them are optional properties. So what we're looking at right here now, right? That is the full definition for this object here. And if you looked at the full definition, you would see that there are many properties that I'm not including here. Okay, and that's typical really, because we're accepting the default values. Again, if I go back to that file, you can see that the majority of the properties have a default value. Sometimes the default value, whatever the default value is meaningful for that particular property. So they all have default values, but you can override the default. And as well, you can see that many of them are optional properties. Okay, that's just kind of a bit of background stuff more at the CDK level now than at the Lambda level. I'm just illustrating it in the context of Lambda, but you can do the exact same with any other L2 construct. So back to our Lambda. So this is the CDK code for our Lambda. And when the CDK code runs, then it will provision a Lambda function. And if you go to the management console and go into the Lambda part of the console, where's Lambda? Down here. And you can see I've got a number of Lambda functions provisioned. If I look at the names, this looks like the Lambda that I was actually looking at in VS Code. And if you go into that, you can find out a lot about the Lambda function from the management console. For example, if you want to see the actual code that has been provisioned for you, you select here and click on the index.js. And you can see here on the right, this is the JavaScript equivalent. This is the JavaScript equivalent of the TypeScript that we wrote for our Lambda function. Yeah. And you certainly don't need to go reading down through that code, but that is the JavaScript equivalent of my TypeScript function, which is this one here, I think. Also, if you go into the configuration tab here and select permissions, here you're told you can get access to the execution role that has been created by CloudFormation, really, with the help of the CDK framework. This is an execution role that was created specifically for your Lambda function. So this is an example now of another low-level resource that was created automatically by the CloudFormation service when I deployed the stack that we were looking at there in VS Code. And if we drill down into it, now you know that the Lambda function, this particular Lambda function talks to a DynamoDB database, and so it needs to have the relevant permissions at the IAM level to interact with the DynamoDB service. And so if we look at the execution role, which we're looking at right now, and we can see that the execution role has two IAM policies attached to it. Now, this language of roles and policies, admittedly now, you have to have some prior knowledge of AWS to understand these things. But so there are two policies attached to this role. This policy here is a default Lambda policy, whereas this one here is a custom policy that was created by the CloudFormation service when I deployed my stack. So this is yet another resource that was created all as a result of my CDK code. And if I click on this to get a look at the detail of the policy, the IAM policy, then, kind of surprise, surprise, the policy is all about giving the Lambda function access to various DynamoDB um, uh, commands, I guess, or um, yeah, commands that the Lambda function can invoke on my DynamoDB servers. You don't necessarily need to, you certainly need to be aware of what I'm showing you here. You won't necessarily always have to go checking these things, but just be comfortable browsing around from the management console level, I guess. Okay, that was kind of a diversion away from, let's go back to here. That's okay. We had the demos and et cetera, et cetera. So I think I'll just keep going on. Let's move on to the next serverless service, which is DynamoDB. So DynamoDB is another AWS serverless service, but it's not a compute service. It's a database service, and it allows us to create. It's based on the NoSQL database model as opposed to the relational database model. There are relational database serverless services, bit of a mouthful, but there are relational database serverless services as well. And we could have looked at those instead of DynamoDB, but DynamoDB would be probably the most popular um, database service provided by AWS. So what it is, as we already know, it's actually it's based on the NoSQL database model. I'm assuming people are familiar with the difference between NoSQL and the relational model. This is kind of the one-liner. It's a fully managed. Whenever we use the term fully managed in relation to AWS, that's really kind of a byword for serverless. So there are still servers that are provisioned whenever you want to create a DynamoDB instance for an application. There is still a server that's taking care of managing the actual data for you, but you don't have to. You don't have to worry about provisioning it or maintaining it or making sure it's up and running and all that kind of stuff. Okay, so it's a fully managed stroke serverless, highly available. It turns out that when you create a DynamoDB database for yourself, and we can see how we'll do that in the CDK code, and you've actually already done it in last week's lab. So we're kind of cart before horse, but that's okay. But when you create a DynamoDB database, automatically the DynamoDB service will make replica copies of your database and manage those replicas for you. It just does that anyway. You can't stop it from doing that. And I'm saying here it actually creates replicas across 3 availability zones. And the point of that is to ensure that your database is always available to the rest of your application. Just in case one AZ zone is inaccessible from a networking point of view, then it just goes to the other AZ zones that it has made a replica copy. So these replica copies are being maintained every time you make a change to your database, i.e. add a record, update a record, etc. Then DynamoDB will automatically replicate that change across each replica copy. Yeah. I'm saying it's a schemaless. Well, all non-relational databases would be regarded as schemaless. Schemaless means that each record in a particular table of a DynamoDB database, each record can have a different structure from other records. There is no overriding structure for each record in a DynamoDB table. Okay. Um, Now you may want to have the records in a DynamoDB table to have the same structure, but if you do, you have to programmatically take care of that. Let's say at the Lambda level, if it's Lambda that you're using as your compute um, option. Okay, so I'm saying records on the same table can have a different set of attributes. And in fact, if you start investigating DynamoDB a little bit more, then you find that, okay, it's a non-relational database, but it has aspects to it that you won't get in other non-relational databases. The most common other non-relational database that you may have used would be MongoDB, for example. But there are fairly distinct differences between DynamoDB and MongoDB, for example, which we won't necessarily get into, but take it from me that there are. DynamoDB was really aimed at very large databases, like in the 10x gigabyte size databases. Anyway, I'm saying here that DynamoDB does not support joins. So, in the relational database model, you have this notion of referential integrity, which really translates into having foreign key fields, which links one table to another table. You don't have any of that in DynamoDB. If you want that kind of feature in your database, again, you're going to have to do it at the programmatic level. And the whole point of not supporting database joins is the whole point is to improve the scalability of your database. If joins are a really important feature for you, then you shouldn't use DynamoDB, possibly. Maybe you should switch to using a relational database option that's provided by AWS. Also, you should consider denormalizing your normalization is a big aspect of relational databases, but for non-relational databases, which includes DynamoDB, you should possibly consider denormalizing your data. So we're not as hung up about having uh, uh, duplication of data in our DynamoDB database as we would be if we were using a relational model. And again, that's all because of the scalability properties that DynamoDB has. DynamoDB is fully integrated with IAM, so obviously we need to have security around the data in our database, and so we achieve that using IAM policies. So it's fully integrated with IAM. It supports event-driven. Well, we won't get to look at that, but you can set up a situation where if a change happens to a table in your DynamoDB database, maybe you want that to trigger the execution of a Lambda. Okay, that would be a typical example of what we might call an event-driven architecture feature in our application. But fortunately, we won't have time to look at that. Okay. Just the terminology of DynamoDB slightly different, but okay, well, tables is not different. So a DynamoDB database is comprised of tables. That's the same as in the relational world. Saying each table has to have a primary key. That's the same as the relational database world. You have to declare what the primary key of a table is at table declaration time. Now, we've also said that DynamoDB is schemaless. So while every table has to have a primary key field, or we don't use the word field, we tend to use the word attribute. Every table has to have a primary key attribute. The other attributes of each record in a table can vary from record to record. Okay, that's what we mean by schemaless. But the schemaless does not extend to the primary key. The primary key has to be consistent across all records in a DynamoDB table. And again, we actually don't use the word record. We talk about items. So each table consists of items, but when we talk about items, that's really a record in old terminology. Each item has attributes. Okay, we would have used the term fields in the relational world, but we talk about attributes. The schemaless, yeah, so I mean, I've kind of already made this point here, that the set of attributes for a particular item in a table, the set of attributes can be different from item to item within a single table, right? But all of the items in a table, the primary key attribute has to be the same for each item in a table, which is what I'm kind of saying here. DynamoDB has its own data type system. And so obviously it has the notion of scalars, which are the things that we'd expect them to be. It has document types. So a single attribute in an item in a table can be an actual document, where a document is, you know, a set of key value pairs. Document is like a JSON document. Okay? Again, I'll repeat that. A single attribute in an item of a table can be an entire document. Or it can be a list, or it can be a map. Well, a map and a document are kind of the same thing, but also it has within its set, its data type system, it has the notion of sets. So you can have a set of strings, which is a bit like an array of strings, but in an array there can be duplicates. Clearly in a set there cannot be duplicates. And so it would actually ensure that you don't have more than 2 entries within a string set that have duplicates. You can have a number set and you can have a binary set as well. So scalars are the same as everywhere. Documents, that's kind of unusual to say that a single attribute can be a document. And the sets is kind of unique as well to DynamoDB. So the primary key part, the primary key attribute of a table, that's kind of important. And as I said, you have to declare that at the very beginning when you provision the DynamoDB database. Now, there are 2 options available to you. There's what's called the simple option, which is your primary key just consists of 1 attribute. And when that is the case, the other name that's often given to that attribute is the partition key. We'll see where this name partition comes from in a second. But we're saying that the primary key just consists of 1 attribute, which is also called the partition key. You've got to make sure that this partition key is unique for each item in the table, which is kind of what we would, when we would normally talk about primary key, that's what we would say. It has to be unique for each item. Secondly, the partition key value range has to be very diverse. It has to have a diverse set of possible values because, well, we'll see why because in a second. And so here's a simple example. If I've got a table of users, then the user ID would be a candidate for the primary key for that table. If I just flick forward, this is your kind of classic example of, excuse me, of a DynamoDB table holding customer orders. Okay, it's fairly standard, admittedly, and where in this table I wanted to have order number as an attribute, customer number as an attribute. What else? Order date, total value, and there'd be some other attributes as well. And I've decided I'm going to use order ID or order number as the primary key for this table. And it's an example of a simple primary key because it only consists of one attribute. So nothing unusual there really. We could easily be talking about a relational table when we look at this, but okay, back to here. So that's option one. Option two is when your primary key is what's called a composite key. And if it's a composite key, then it's composed of the partition key attribute and a sort key attribute. These things have different names as well. We often refer to the sort key as a range key. So now we're saying that in a table with a composite primary key, you could have a number of items that have the same partition key value, but when you combine the partition key with the sort key, that combination is unique or has to be unique. The combination, yeah, that's okay. And I suppose if I just flick forward, so here's the exact same table, but I've decided to use a composite key here. This again is a table of customer orders, but I've decided that I want this table to have a composite primary key where the partition key part of the primary key is customer number or customer ID, and the sort key is order ID. There, order ID. And so they presumably a customer makes more than one order. So in this case, the partition key will have multiple items with the same value, but when you combine the order number with the customer number, that combination must be unique. Now, why would you choose this option over the simple option? It comes down to the kinds of queries that your application may need to perform against the table. Let's just leave it at that for now. So there is a reason why you would choose one over the other for essentially the exact same data in this case. And we'll see where that comes into play in a few slides. So back to here, composite key combination has to be unique. What results in with a composite primary key is you have what are called item collections in a table. And again, if I just, sorry now for flicking back and forth, but if I go back to here, right, assuming customers make more than one order, then you're going to have a number of items, i.e. records in this table that have the same customer number, but a different order number. Now, the set of items that have the same customer number, we refer to that as an item collection. And what you are guaranteed when you use this composite primary key is that all of the items that have the same customer number, they will be stored beside each other. And if you ever need to retrieve all of the items with the same customer number, you will receive them in order number sequence. So DynamoDB takes care of that automatically. But we have this notion of an item collection when we have composite primary key, a composite primary key table. And again, if I go back now again, so we have, it results in item collections within a table. The item collections are grouped by partition key, they're grouped by customer ID, and they're ordered by the sort key. They're ordered by the order ID in our case, in our example. Okay, this is just another example, but I think the order example is probably the easier one to relate to. I'll pause for a second just in case I've overcomplicated that. Are there any questions? No. Okay. Now we're using the term partition key there when we are talking about primary key. In this simple example, the primary key consisted of the partition key. In the composite example, the primary key consisted of the partition key plus a sort key. Now, where does this partition term come from? You see, it turns out that DynamoDB automatically stores your table across multiple nodes or computers on its network. Okay, so I also said when I started talking about DynamoDB, I said that it was really aimed at very large scale databases. And this is becoming evident now from this kind of slide here when we start looking at the way it actually stores your table um, on kind of on a hard disk. Okay, so in this example, it looks like that my table, this is for a single table now, my table is actually split across 4 partitions. These are not replicas now. This is a very different thing. These 4 partitions are used to store one table. And because there are replicas, there are actually 4 other partitions having replica copies of these ones. Okay, so anyway, my table is split over 4 partitions. That happens kind of automatically. Essentially, once your table goes above 10 gigabytes, then DynamoDB will automatically start partitioning it. Again, you don't specify how many partitions you want at table creation time. DynamoDB will take care of this automatically for you. And once it sees your database starting to grow, then it may decide, well, we need a 5th partition now, and sorry, it will automatically redistribute the current 4 partitions across 5 partitions. Your 5 partitions now they won't be full up, obviously. Um, so that's kind of how it works behind the scenes. It partitions a table, uh, i.e. it distributes your data across multiple partitions. And so, for example, if you want to write an item to a table, the command in DynamoD is to put an item. So let's suppose we want to put an item and we specify the customer ID and the order ID. If we stick with that example, there's a bit, sorry, there's a particular part of the DynamoDB service called the request router. And what it does is it takes the item, it identifies the partition key part of that item, which in this case is customer ID. It subjects that customer ID value to an internal function. And what the function does is it returns the partition that this item should be stored in. So let's suppose it decides it should be stored in partition 2. So this is kind of a hashing function that we don't need to know about how, the workings of it. It's probably proprietary to DynamoDB anyway. And so equally, if we want to read an item, and the command in DynamoDB is to get an item, we have to specify the primary key of that item. Now, because my primary key is a composite primary key in this case, then I have to specify the customer ID part and the order ID part. Again, what DynamoDB does is it takes the partition key value, puts it through this special hashing function. It will return, let's say, partition 2, because it's that particular customer ID value, and it will retrieve that item from that partition. Now, the whole rationale behind all of this is no matter how many partitions, no matter how big your database is, then this partitioning approach will guarantee consistent performance or responsiveness by DynamoDB to, let's say, read requests and similarly write requests. So it's all really aimed at this scalability issue. and consistency of performance as well. Consistency of performance is you're kind of guaranteed because there is an upper limit to the size of a partition, no matter how big your database is. Dynamo, AWS are essentially giving you guarantees in terms of the performance of the service in relation to reading and writing records, items, sorry, to a table. Uh, so if I go back, sorry, to here, you know, we're saying the primary key just consists of the partition key. With partition key now, we kind of have some sort of meaning for where that term, what that term relates to. It relates to the partition of the table that the item is stored in. Okay, so DynamoDB is aimed at, as I said, very large databases, and we can see some evidence now of where that scalability is achieved or how that scalability is achieved. Okay, maybe all we're really interested in is, well, how do I provision a DynamoDB table? And we talk at the table level. We don't talk about provisioning a database. Now, if you read about DynamoDB at all, one of the things you will come across, and it's really kind of off-putting and doesn't make any sense initially, but if you're to use DynamoDB properly, and reveal we won't be using it properly in this module because we don't have time, but if you were to use it properly, your DynamoDB database should consist of just one table. So everything should be stored in one table. So customers, products, orders, etc., etc. What are, irrespective of how many different entities that might make up the modeling of your database, you actually store all of them in one single table. Now, clearly, there are techniques as to how you come up with the primary key for that table because it's essentially storing different types of information. There are techniques and patterns for designing the primary key, whether that be composite or simple. So that's just by the way, right? So we don't provision a DynamoDB database. We provision a table. And so here's some code extracted from a stack file. So the construct in this case is surprise, surprise table. So that's another L2 construct. Has the exact same number of parameters, the constructor. What stack do you want to link the table to? What ID do you want to give to the table? And then these are the properties of this particular L2 construct. I wouldn't worry about the first one. I'd say the default is this anyway. Here we're specifying the partition key. This is actually the table that you would have provisioned in last week's lab, actually, now that I think about it. So that's fine. The removal policy, that's kind of useful when you're at development stage. Like every time you destroy the stack, you want the table to be destroyed as well. Clearly, that wouldn't be a clever thing to do if you're talking about a production environment, but certainly in a development environment, having the removal policy as destroy is useful. Not sure what the other option is, but the other option effectively it means that when you destroy the stack, the table remains there. Okay, and table name, that's okay. That's just the table name from DynamoDB's perspective. And you've done this last week, so again, if I just flip over to the DynamoDB service, And in terms of tables, do I have a table? Oh yeah, I just have one table at the moment. And you can drill down into it. And if you want to just see what data is in the table, typically you go here. And then you can see the items returned and so on. It looks like this table, sorry, let me just do that again. Sorry, I'm in the wrong region. See here, I'm up in US Virginia North. That's kind of, I know some of you have come across this problem. It kind of defaults back to that region. So that's not the region I want to be in. It's in EU West. Where's Europe? Oh yeah. Um, right, here's my movies table. If you want to see the actual data. Okay, and well, it's always going to be the partition key is always going to be at the beginning and all of the other attributes. And you can see some of the attributes, like here's an example. Can't see the detail, but here's an example of an attribute it's an array of scalars. And the other attributes then are simple enough types, scalar types. But yeah, so this is an array of scalars, but if I could have an entire document here, which really translates into it's a JSON structure here, could be one attribute within my table. That's what I was talking about there earlier on. Okay, let's go back to the slides. Every, I've said this a number of times, but every AWS service uh, has an API interface, a web API interface, and that API comes with an accompanying SDK. And in the case of the DynamoDB service, the SDK provides essentially three main classes that you can use to interact with the DynamoDB service. So these classes here are what you would use within your Lambda function or whatever code you were using to talk to DynamoDB. It doesn't have to be a Lambda. You could have a piece of code, TypeScript stroke JavaScript code that you're running from just your desktop machine. And you would simply just import the DynamoDB SDK. And then in order to talk to DynamoDB, which is remote, you would use these classes here. This one here is kind of the base level class. This is the class that you would use when you're using the streaming part of DynamoDB, which we're not going to look at. And this is the class that you would use when you're trying to do normal kind of read-write operations. So this DynamoDB document client class, it actually uses this one internally. So as you may have seen from the Lambda code that you wrote last week, the Lambda code that was talking to DynamoDB, we first of all create an instance of this within the initialization part of our DynamoDB, within the initialization part of our Lambda function. So we establish a connection with DynamoDB, but then in order to communicate with DynamoDB, we create an instance of this class, but we pass it a reference to the instance of this one. You could talk to DynamoDB directly using this class, but it's quite low level and it's more granular, whereas this is at a higher level of abstraction and easier to use from a programmatic point of view. Okay, and that's what I'm showing you down here is just from the package.json. Turns out that the DynamoDB SDK, because it's quite large, it's actually broken up into a number of separate libraries. Um, and depending on what kind of interaction you want to do, that really determines how many of these you need. In fact, it turns out we will need all three of them. Now, so DynamoDB provides a web API interface. And this is when things start to differ a little bit between the DynamoDB NoSQL model and the NoSQL model, that's available from other NoSQL databases. So from DynamoDB's perspective, there are essentially only three types of operations that a client may want to perform against DynamoDB. And the client in our case is a Lambda function. There are what are called single item operations or single item actions. That would be when you want to read a single item, write a single item, update a single item, or delete a single item. Yeah. And clearly for a single item request or a single item action, you have to specify the primary key of that item, whether it be composite or simple. So that's straightforward enough. The second type of operation is a query operation. Now, the only type of table that you might want to perform a query against is a table with a composite primary key. You cannot have a query against a table that has a simple primary key. So in general, a query operation reads a range of items. Now, range here, maybe I should have used the word collection, but it reads a collection of items. And we know what collection means here. A collection means all of the items have the same partition key, but a different sort key. Now, you may want to read the full collection of items. So in relation to our customer and orders, that would be we want to read all of the orders for a particular customer. Or you may want to only read a subset of the orders for a customer. Or equally, you may want to delete all of the items or update all of the items. It doesn't have to be a read operation. Requests must include the partition key. Okay, that's all right. Only suitable for tables with composite primary keys. I've already made that point. The query results. Now, this is where partitions come back into play again. The results of a query request will always come from the same partition for that particular table. Okay. And again, you cannot get around that. So, sometimes you'll find this to be quite restrictive if you come from a relational database background. So the query results are always from the same partition because we know that all of the items, let's stick with our customer and order example, all or some of the items related to a particular customer will come from the same partition where customer ID is the partition key. So if all of the items have the same customer ID value, that means they all map to the same partition within our set of partitions for our table. So they all come from the same partition. That's fine. The third type of operation is the least efficient, which is called a scan operation. And in a scan operation, again, you want to read a bunch of items. I should have used a different term here. You want to read a set of items or a bunch of items. But in this case, you don't have to be specific about the partition key value. And that means then that the items could come from different partitions. Now, this is where DynamoDB kind of falls down. It really doesn't like these type of requests, these scan requests. If you have a scan request, DynamoDB actually has to check every partition of your table to collect up the items that you're looking for. And clearly that's an inefficient operation. So we minimize the amount of scans that we need to do. Queries are performant, single item are very performant, scans are not. Here's an example of a single item request, but I suppose more generally, this is typical kind of Lambda code for talking to a DynamoDB database. And again, you've seen this last week. So if you took the time to study it, there isn't really anything new here, but just to break it down, I'm importing the classes from the SDK that I need, which in my case is the DynamoDB client class. That's the kind of low-level class that's available to me. I'm also importing the document client class, which is the more the higher level class, if you like, within the hierarchy of classes. I am establishing a connection with the DynamoDB service. This is an example of initialization code in my Lambda function. And then within the handler part of my Lambda function, I am creating a DynamoDB document client instance, but I'm using the DynamoDB client within that. This is what I said, that this class here uses the low-level one to do the actual communication for it. The marshalling and unmarshalling. Now, in our TypeScript code, we are dealing with TypeScript data types, which are really JavaScript data types. But DynamoDB has its own data type system, and I talked about that a few slides back. So we have to convert from DynamoDB's data type system to the type system used within JavaScript. And that's what we refer to as marshalling and unmarshalling. So if we're doing a read operation, we have to unmarshal the data that we receive from DynamoDB. If we're doing a write operation, we have to marshal the data, essentially convert it between the two type systems. Yeah. Now, fortunately, all of that messy low-level stuff is taken care of for us, and it's mainly taken care of by the DynamoDB client, that low-level class. But and so in here we would specify the nature of the marshalling and unmarshalling. It's typically fairly boilerplate code. But if you had something out of the ordinary, you can configure it. So once all of this is done, we now are able to talk to DynamoDB. Yeah, note we haven't specified a table anywhere up here, right? This is all establishing the connection with DynamoDB. And in fact, all of this now is really initialization code. In the handler then is where you put the code where you're doing the actual operation, be it a read or write or whatever. The style of coding, what you'll notice if you use more than one if you use more than one AWS service. Now, unfortunately, I think DynamoDB is the only service that our Lambda functions will be interacting with. But if you study AWS serverless a little bit more, and so, for example, if you want to write a Lambda function that talks to the SQS service, or a Lambda function that wants to talk to the S3 service, what you'll notice, which is really kind of a nice feature from the SDK perspective anyway, is that irrespective of what service your Lambda is talking to, the the programming model is almost the exact same for all of them. Now, what the programming model looks like is you send a request to the service, and what you send is a command. So we talk about this is based on what's called the command design pattern. And you can see up here, I'm actually importing the get command. The get command is the DynamoDB command for doing a read operation against the DynamoDB database. Okay, and again, as I said, no matter what service, AWS service, a Lambda might be interacting with, what you would find is that you would have a client for that service. That client would have a send method, and the send method takes one parameter, and the parameter is a command parameter. Clearly, the commands are different depending on what service you're talking to, and clearly the client is different depending on what service you're talking to. But at the higher level programming model, they all have this send method, and they all are based on sending commands. The get command, which is specific to DynamoDB, again, you'd have to look at the kind of constructor for this class. And I kind of showed you how you might do that within VS Code by just clicking on it and you would get it. But you can see now that in terms of the get command anyway, this is where we actually specify the table that we want to interact with. Now process.env.table. You can pass environment variables into a Lambda function, and again, you would have seen that last week. So this expression here evaluates to the name of the particular table that I want to talk to, where name is this thing here, really. You could hard code it, but clearly that's not a good idea. You specify the key. Now, we're not saying whether it's a composite or simple, but because this particular table is using a simple primary key, then, and we said that the primary key, the partition key, sorry, was movie ID and an actual value. Again, as I said, it's kind of you've kind of already seen this from last week's lab, but okay, moving on. So, three types of operations. Again, I'm doing a lot of jumping around now, but back to here again. Simple operations. So this is an example of a simple operation. Yeah. Query operations, that's the one that causes people slight issues maybe initially. Scans are straightforward enough as well. So let's talk a little bit about query operations. So query requests return items based on the partition key and the sort key. For the partition key, the only thing you can say is, I want the partition key to be equal to a specific value. So the only operator that you can use when specifying the partition key for a query is that it has an exact value and you're specifying it. You can also specify the sort key in a query. If you don't specify a sort key, then you are saying, I want all of the items that make up a collection for a particular partition key. E.g., I want all of the orders for customer number 12345. If you want to narrow it down a little bit, then you have to specify the sort key within your query. And there are a number of operators available to you for specifying the sort key. You can say, I want it to be equal to an exact value, less than or equal to, less than or equal to, etc., etc. So clearly, these operators here only make sense if the sort key is a numeric type. If the sort key is a string type, the only operator you have available is this. It begins with something. That the string the sort key string value begins with some substring. You don't have contains or ends with, so it's pretty restrictive. Um, right, so that's that. So if you want to do a query, specify the exact value of the partition key, you must do that, and optionally include some information about the sort key in your query. Um, in the query, you can specify a filter expression, but the thing you need to remember is that the filtering is not done by DynamoDB. The filtering is really carried out by the DynamoDB SDK. So it's really done at the client side. So you don't gain a whole lot from performance point of view if you do need to have a filter. But at least the filter expression will reduce the number of items that are actually given to your Lambda function. But again, as I said, the filtering is actually done by the SDK, and the SDK resides in the same execution environment as the Lambda. The SDK does not execute over at the DynamoDB side, the kind of server side. Query responses. Oddly enough, you're only limited to 1 MB response size. Okay, so if it goes over 1 MB, you have to do some thinking. If you know it's going to be more than 1 MB, then you can specify in the query request to limit the number of items that are returned back to your Lambda function, returned back to the client actually. So if there was 100 orders for customer number 1, 2, 3, 4, 5, and we're only interested in, let's say, the top 10, then we could specify that by using the limit parameter in our query request. By query request, I simply mean, this code here. Clearly, it's not going to be a get command. There is a query command as well available to us. And also, the query command supports pagination. So again, going back to there are 100 orders for customer number 1, 2, 3, 4, 5. Well, we can actually get DynamoDB to return the first batch of that 100. And then you can tell it, give me the next batch and the next batch and the next batch. Okay, so that's what we mean by pagination. So that's built into it, mainly because of this kind of fairly restrictive 1 MB limit on the amount of data that can be returned at any one time by DynamoDB back to our Lambda function. And clearly this has got to do with kind of guarantees related to performance. Again, I'm kind of reinforcing something here, but it is something that people find they don't tend to grasp it initially, nor did I, which is that query actions, you can only query on the basis of the primary key. And this is our customer order example. So we can only run queries against these two attributes of our orders. If we want to query against the non-primary key attributes, then you have to use the scan operation. And we already said that a scan operation means that DynamoDB actually has to check every single partition to find the items that you're looking for. Query example. Okay, well, sorry, this is more than a query example. Well, yeah, query example, as we know, sorry, a query example, queries only apply to tables with composite primary keys, yeah. So I've got a table here, and you will be playing with this table in this week's lab. I've got a table that contains information about the cast for each movie. Okay. Um, okay, so the cast or the members for a movie, and the part the partition key. Again, I've stayed with movie ID as the partition key, but I've decided to use the actor name as the sort key. Probably not the best option, but it's the only one that I could come up with. Um, so it's a string, clearly. The sort key is going to be a string rather than a number. And uh, this combination gives us the primary key for this movie cast table. So clearly a movie has more than one cast member in it, but the combination of the cast member, i.e. the actor's name, and the movie ID, that combination is going to be unique within my movie cast table. This table now is meant to contain details of the cast for all movies, not just one movie. And the rest then is as before. So this is from the stack file. Down here then is from the Lambda. Just put them together into one just for convenience. And you can see here that I'm sending using my DynamoDB document client. I'm sending a query command in this case. And these are some of the properties that I need to set. I need to set the table name. I need to specify. So the key in this case is specified using kind of an expression, using an expression. And here's the expression over here, that the movie ID has to be equal to a specific value. This is just a placeholder, which I actually initialized down here. The key has to equal that. We said that the partition key, the only operator you have available to you is the equals operator. Logical. And now this is how we specify the condition associated with the sort key in TypeScript anyway. Okay, so there's a convenience function called begins with, where we specify the value uh, that we want to restrict our query on. So the the actor name has to begin with this value. Where does this get its value? Down here. So I'm only looking for actors whose name begins with Bob for movie 1, 2, 3, 4. Actor name here, sorry, actor name, sorry, no. Oh yeah, actor name here is the sort key up here. Right, a little bit more long-winded, but that's the nature of queries. And, you know, these two values uh, combined are going to be unique, and these two values relate to the two parts that make up my composite primary key, my composite key, sorry. The composite key can't be more than two attributes. You can't have a three attribute primary key. Okay, let's see. Now, clearly, it's quite restrictive, as I've already said. The querying is quite restrictive. Now, if this was it, right, then it would mean that the only basis on which we can query this table, this movie cast table, we can only query it on the basis of a movie ID and that the actor's name begins with a particular substring. But supposing I wanted to query my movie cast table based on the movie ID and the name of the role of that actor within the movie, right? I can't do it as it stands. Or there might be some other combination of movie ID and some other attribute or property of uh, actor that I want to do my querying on. And so for those other cases, you can actually also specify what's called a local secondary index for a table. So these local secondary indexes or LSIs, they only apply to tables with composite primary keys. Uh, the LSI is based on the same partition key, but an alternative choice for the sort key. The LSI is stored. It's stored within the same partition as the items it relates to. We're back to this kind of partitions thing now again, right? Okay. So the is stored locally to the partition key. You can have a maximum of 5 LSIs per table. So there is an upper limit. And we use the LSIs with our query actions. Okay, moving on. I'm just reading out the stuff, but the attribute chosen for an LSI can either be a scalar string, a scalar number, or a scalar binary. Nothing unusual there. The LSIs must be defined at table creation time. Each LSI entry, okay, this is where it gets slightly away from the norm. Maybe what's on the next slide? No. If I switch over to, let me think, no, maybe if I'll just stick with the slides. What I'm getting at here is if you've got a partition, let me just draw it up here if I can. You've got a partition, and what's going to be stored in that partition is what we call the main index. So in the case of our movie cast, the main partition, the main index, sorry, is the one where the sort key is the actor's name. Isn't that what we said, right? So I'm just going to draw a section here within my partition. Can I check if people can still hear me and see my screen?
Yep.
Okay.
Yeah.
Did it break down on your side?
You kind of just went offline.
Yeah, yeah,
Yeah.
that's the problem. You see, I'm actually running this off the Setu Red wireless network, which is not great, but okay, we're still back on track anyway. Let me just collapse that. And you can see my PowerPoint slides now, yeah?
Yep.
Right. So this is a single partition now. Single P for partition. Single partition within my table. Part of that partition is going to be occupied by what I'm calling the main index part of it. Within this main index will be uh, a lots of items or records, collections of items. They'll all have the same movie ID, but a different actor name. And let's supposing it's because it's only one partition, it's only some of the data within my table, but it's going to be replicated across the other partitions. Now, if you want a local secondary index for this table as well, then that local secondary index is going to be stored on the same partition, and the entries in this LSI, okay, if you can make that out, this local secondary index will relate to the items that are in the main index. Yeah, so whatever the movie IDs are on this particular partition, whatever movie IDs were mapped to this particular partition, that's supposing there are a couple of hundred of them, then the local secondary index will only relate to those particular movies. That's what we mean when we say that the LSI is stored local. What did I say? Did I say it down here? Each LSI, where did I say it? The LSI is stored local to the partition key. Right. That's the first point. But the second point then, it relates to what I'm talking about here is a projection. Now, you might think, coming from a relational database world, that an LSI contains, let's say, a movie ID and then a reference to the corresponding item or record up here. But that's not the case. The LSI potentially has a full copy of the item or record. It actually has its own copy of the item that it relates to. So for movie 1234, actor Joe Bloggs, that entry here, that item here, will have a full copy down here as well, and all of the other attributes related to that particular cast member within that particular movie. That's what we mean by projection. However, maybe you only want some of the attributes projected down to the local secondary index. And you can specify which particular attributes from the main index should be projected down into the local secondary index. So you can be, if there are too many items, too many attributes, and you're only going to be interested in a subset of those. How are you going to know? Well, it'll depend on the types of queries that you want to perform against this table. The whole point of having an LSI is because we want to be able to perform more than just the standard type of query, the standard being the one that's based on the main index. And if you've got, that's why there's actually an upper limit of 5. Where did I say it? It's somewhere over here. I said there's an upper limit of 5 LSIs per table. So you can only have 5 LSIs within a partition. And because an LSI potentially is a full copy of the main index, that's why, the maximum size of a partition is 10 gigabytes. So it wouldn't take you long to chew up 10 gigabytes and hence require many more partitions for a particular table because of the way these LSIs actually work. So that's kind of going on behind the scenes. Of course, at a programming level, you don't necessarily need to know that kind of lower level detail, but there you go anyway. You're getting it for free. And that kind of leads on to this point down here at the end, saying a table has, number one, it has a primary index or main index. Optionally, then, it has multiple LSIs, all stored within each partition, sorry. And there is something called GSIs as well, global secondary indexes, which we won't look at. I took this straight out of the DynamoDB documents. So I didn't have to work too hard to get this example. We moved away from the customer. Could have used the customer, but this is an example. Let's suppose we've got this table, Maria, for some social media app, but the social media app relates to, people that are interested in the AWS world. So it looks like this table is a table for storing discussion threads, okay? And the discussion threads specifically in relation to the AWS platform. And so the table's partition key is an AWS service name like S3 and all of the other ones. The sort key is a subject area within that relates to this particular service. So we're not being specific here, but it's some sort of string, I guess. So that combination of um, service name, which is our partition key, and kind of subject area, which is our sort key. This now, let's say, is our main index. And then there's other attributes as well. Particularly, there's a last posting on this particular thread, the date of the last posting. So I can query this table by saying, for example, give me all of the threads for the S3 service where the subject area begins with some substring, and it'll pick out the subset of the items from this table. But let's supposing I want to also be able to query this table along the lines of uh, give me all of the threads, again, let's say for the S3 service, where the date, the last posting on that thread was, let's say, 2022, in 2022. Now, as it stands, if I didn't have LSIs available to me, I can't run that kind of query against this table. The only thing I could do is program a scan request, and the scan request or the scan command would require DynamoDB to look at all of the partitions for this table and do its kind of number crunching that way. Read all of the records and filter out the ones that it needs and then return those back to you. But clearly, this could span over tens of partitions. So that's not a great from a performance point of view. But enter LSIs means if I now can actually define a local secondary index, partition key is still the same, but the sort key in this case is the last date, last posting date for a particular thread. Now, unfortunately, DynamoDB doesn't have a date type natively, so we have to treat this as a string actually. And given the way the string is structured, the only types of queries we could do would be along the lines of all of the threads for a particular service in a particular year, or maybe in a particular year and a particular month of year, that kind of idea. So, um, but it's better than the scan operation. I pause again in case there are any questions related to LSIs. No. If I go over to VS Code, sorry. And in fact, no, if I go over to the lab, so this is the lab that you did last week, but if I go into it, I've added a new section here, and this new section steps you through essentially that kind of movie cast example that I was referencing there from the slides. So you set up a second table called the movie cast table, and it has an LSI, and you issue queries against the main index and the local secondary index as well. So you can work your way through that. I'll just briefly show you the kind of results. Here is the DAC file, and I have my movie table from last week, let's say. Here's my movie cast table. Now, I want to re-emphasize, okay, the movie table, its primary key is based on movie ID, and I've got my movie cast table, which is a separate table. It all has also has a partition key based on movie ID. But DynamoDB does not help you in any way uh, by ensuring that there is kind of a link between these two tables. Clearly, there is a link between them from our perspective, just as ordinary, from our understanding of what's stored in those tables. But DynamoDB treats these two tables as completely independent of each other. There's no referential integrity, no joins between these tables. Okay, anyway, my movie cast table partition key is movie ID. Sort key, I've chosen actor name. In terms of seed data, if I jump to there, my seed data, I've just kept it fairly simple. So I've got a movie cast type, movie ID, actor name, role name, and a description of the role. Yeah, that's what the full table set of attributes are going to look like. Back to here, sorry. Other than that, there's nothing unusual from a seeding point of view. This custom construct that you would have seen last week. Sorry, I beg your pardon, look at the wrong thing. This is how we define a local secondary index for a table. It's pretty straightforward. We came across this uh, custom construct. This is a fairly specialist kind of construct that the CDK people provide us with, which allows us to, for example, in this case, we're using the construct to seed our table or tables. You can actually use this construct to perform any kind of application startup functionality. It's not just database seeding, but that's the only use case we have for it. But within this, am I looking at the right one again? I am, yeah, sorry. So I'm actually using it to seed both the movie movie table and the movie cast table. So you can actually seed multiple tables. If I was really using DynamoDB properly, then I would store movie cast and movie data all in the same table. Um, but we're not going to get into that because we don't have time to look at the minutiae of that. And then the rest is about a, was I referring to the wrong thing there again? No, the rest then is just lambdas, get movie lambda, get movie, get, uh, get, get movie by ID lambda. Oh yeah, that's just the URL for the lambda. And then I have a get movie cast lambda as well. And if I just jump over into that one, which is here, uh, the way I want to query this table, if I go to the lab, maybe, apologies now, I'm kind of slightly jumping around the place, but the way I want to be able to query this movie cast table is I want to be able to get, let's say, all of the cast members for a particular movie. I want to get um, only those cast members that have I want to get, sorry, specific actors in a movie, or I want to get information on a particular character or role in a movie. Three different types of queries. Now, because my movie cast table has a composite primary key based on the movie ID and the actor's name, then the main index will take care of these two types of queries. But if I want to get information related to a particular role within the movie, then I need a local secondary index, and I have that defined in my CDK code, and you can look at the detail later on. In terms of how I actually issue the request from the HTTP level, then I'm going to use the HTTP query string to do that. And that's what I'm showing you here. So the query string, if the query string just has a movie ID and a value, then we're essentially looking for all of the cast for a particular movie. Or it might have a movie ID and an actor name within the query string. In that case, we're looking for only those movies where there was an actor whose name began with a certain substring. And thirdly, the query string, the HTTP query string, might have a movie ID and a role name. In that case, we're only looking for entries related to a particular movie where there was a character or role within that movie whose name began with a certain substring. And that means then in my lambda function itself, here is the lambda. I essentially have to grab the query string. By the way, the query string is actually available to me within the event object that's passed into my lambda. Uh, and I'm extracting the query string from the HTTP request. And then I'm examining that query string. If I scan down to here, I'm checking, does the query string have role name as one of the options within the query string? If it does, then issue one particular type of query request. Or does it have actor name within the query string? If that's the case, I want to do a query against the main index. The third option is if it has neither, it only has movie ID. And in that case, I'm also doing a query, but I'm just querying based on the basis of the primary key. So there's a lot of options within this lambda function because it turns out that this lambda function can be invoked with in various kind of scenarios, let's say. And eventually then I return the results back to the user. Now I've already deployed this stack, so just to see a simple example of it, if I use Postman, you should all become very familiar with Postman because it's the only way we're going to be able to test uh, our web APIs, even though this is not really a web API so far. We're just using raw URLs attached to each Lambda function, and we have two Lambda functions. But the URLs that were generated when I deployed the stack, there was a URL generated for my two Lambdas. And where did I put them? If I go into this collection here, again, just briefly on Postman, if you need to install the Postman app, and with Postman, what we do is uh, we also create collections, but it's not collections from a DynamoDB perspective. It's collections from a kind of HTTP collection perspective. And so the way you create a collection is if you just go here, create a blank collection, give it a name. Let's just call it demo. Demo. And you can associate variables with a Postman collection. If you just select variables there, and variables are just key value pairs. So set up whatever variables make sense. And then within a collection, so I have my demo collection somewhere. Here's my demo collection here. And then within a demo collection, you can create requests. So if I select this and go new request, wherever it is, by not seeing it, add request. And a request then is, you select what type of request is it? Is it get, put, post, or delete? What's the URL of the request? And you can also specify the query string. Now, I've set this up already. So if I go to this collection here that I have, which I've called DynamoDB queries, I have two variables that I've declared. And the variables, essentially, in my case, anyway, the variables contain the URLs, the function URLs that were generated by the CDK when I deployed my stack. If I go back to my stack, I'm generating a function URL here. And similarly for the other, I have two lambdas. So I've got two URLs. And so I just grabbed those URLs and I pasted them in here and I gave them meaningful names for myself. So that's my collection. And then if I look at the actual requests within that collection, so if I take, let's say, this one here that I created, it's a GET request. This is how I can reference the variables at the collection level. So that expression there will evaluate to the function URL for that particular Lambda function. And here's the query string part. Now, I didn't have to type this in. The way I set up query strings is by selecting the params tab here, and you just list the query parameters, if you like. There's only one in this case, movie ID. It had the value 1, 2, 3, 4. And so when I set up that parameter, i.e. query string parameter, then Postman will automatically add on the query string here. And that means now if I click the send here, it's going to send a HTTP request to this URL, which is the URL associated with my get movie cast lambda function with this particular query string. And if I click send, here's the result that I get back. I'm getting back oh yeah, I'm just getting back the details of the movie. Did I pick the wrong one? Sorry, I did. I should have picked this one. Beg your pardon. This is the get cast request. The get cat request. Sorry about that. Now, this is the one. This URL is targeting the Lambda that handles requests about cast members. Hopefully, let's just issue the request. So it looks like I'm looking for all of the cast from movie 1, 2, 3, 4. Did you give it back to me? Yeah. So these are actor, um, actor. Okay, actor Alice something, actor Joe Blogs, and actor Joe Clogs, all um, or were cast members for movie 1, 2, 3, 4. If I'm only interested in a subset of that, so in that case, I'm adding a second option to my query string. which conveniently I've set up beforehand. So I'm only interested in, let's say, let's pick this one actually. I'm only interested in actors whose name begin with Bob. Is that what I'm asking? Sorry, whose name begins with Joe. I'm only interested in actors whose name begin with Joe in the movie 1, 2, 3, 4. And I want to unselect this one actually. And so you can see the query string up here. And if I send that, I should only get back, yeah, I get back Joe. Sorry, I get back Joe Clogs and Joe Blogs. So that particular request, if I go to my Lambda, from the Lambda's point of view, this is the Lambda that was triggered. Then it would have it in this conditional statement here. It would not have found role name in the query string. It would only have found actor name. And so this is the actual query that was executed against DynamoDB. And it looks like it gave me back the right results. And you can play with that in the lab yourself this week. Now, as usual, I did not get as far as I wanted to, but c'est la vie. If I go back to the website, okay, so we finished these slides here, but in these slides, we need to talk about a service called API Gateway. And it's with API Gateway now that will allow us to create a RESTful web API interface to our backend Lambdas. At the moment, our Lambdas have URLs generated for them, but those URLs are not kind of connected in any way, even though clearly they all relate to the same kind of application. If you like, they all relate to this kind of movie related application. But when we bring in the API gateway service, we will have sort of a single entry point to the various Lambdas that make up our movie application. And the URLs for those Lambdas will all be kind of connected as well, if you like. I was hoping to cover some of that today, but doesn't look like it. How are we doing on time? Kind of in between times, really, but is there anything useful that I can do? Perhaps not. Okay, I'm going to have to stop there actually. Now, as you know, next week is what we call reading week. So there are no lectures next week. So this is week 4. I'm hoping to get everything done in the next 2 weeks with you, week 5 and 6. So I need to cover API Gateway and also a service called Cognito, which will provide kind of user authentication and user authorization aspect to our web API. Right. Are there any closing questions? No. So that means you only, from a lab's perspective, you only need to go back to the lab that you were working on last week. This one here, you could walk through. If I go into this lab, even though we haven't covered the web API, you could certainly you could nearly do all of it, but you could certainly work your way through everything up to here, let's say. and just see how you get on. There are no exercises, there are no challenges kind of within the first few sections, I think. If I scan down, there is an exercise there. Okay, maybe you can stop at that level or even try the exercise, but you could certainly work through the first two parts of this lab, given that you've got an extra week kind of uh, to play with. But certainly you need to go back to the first lab, and as I said, work your way through this part here. Okay, I'm only dawdling now at this stage. There are no closing questions, it sounds like. No. Right, I will talk to you on Thursday in the labs. Thanks, bye-bye.